Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 47, I will give you an overview of the Cube software. So the different concepts that we will cover in this lecture will be on our introduction to the Cube software. We will discuss about the different components of the Cube software, the Cube software interface, and then we will talk about how Cube software is integrated with ArcGIS and how that could be used for both for data editing as well as data visualization. We will talk about the different Cube extensions, and together with all these extensions, we can actually develop a land use transportation model. So, a land use transportation integrated model in Cube through using Cube Land, that will be our final topic. So, to introduce Cube, we have already discussed about the base concepts of our transportation software, which can be done using a transportation software, and we have discussed about the capabilities of Cube as well as PTV VSIM as well. So, to introduce Cube, it's a comprehensive and integrated platform for developing wide range of transportation planning models. So, that means it is not one component, there are many components, and using that we can do different types of analysis that is required within the overall gamut of transportation planning work that has to be undertaken. And the Cube is a popular model which is used worldwide in many places, and in many cities have adopted Cube as to model the travel demand, and it is also used in many places in India as well. And we have in Cube there are two basic modes in which we can work. One is called the developers mode and the other is called the appliers mode. Now, developers mode is when you can both design and develop the transportation model, and appliers mode is when we can apply the model for building, testing and evaluating different scenarios. So, that means not everybody needs to build a model. So, people who are aware of modeling or people who can develop models or calibrate models, they will be using the developers mode, whereas people who just want to apply some model just to test some scenarios or see what would be the effect of a certain temporary restriction that we want to undertake. So, those kind of things could be evaluated using the appliers mode. So, we will apply an existing model to test different scenarios. Now, where is Cube applied? Cube could be applied in different cases. For example, we can evaluate different public transit alternatives. We can decide on road pricing strategies. Different land use developments could be tested, the effect of those land use developments, location of freight terminals, that means if I change the freight terminal, what effect it will have. Now, when we will cover freight in the next module, once we have covered freight, you can always come back and revisit the transportation software, these lectures that we are undertaking, so that you have then you can relate that, okay, how are this software actually helpful for doing freight planning as well. So, just to give you a short overview, this freight terminal locations actually determines what kind of cost that what kind of cost a particular company has to face when it is locating a terminal at a particular location and distributing to different retail in that particular area. So, there could be three alternatives for terminal location. So, to say which alternative is the most beneficial one. Now, this kind of modeling and could be only done if the distribution happening from a particular terminal could be also modeled by the software. For example, a vehicle distributing soft drinks from a bottling plant will probably and maybe or from this freight terminal if it's or just from that particular company, it will do a restocking tour and go from one retail store to another. So it has to be modeled at one go. So that kind of modeling and location of those terminals or warehouses or those industries actually do play a role in what kind of trips would be generated. So this kind of models could be also done. Then we can do freight forecasting, of course, and this is primarily used in Cube. We can do a commodity based model. There are different kinds of freight models. One is a truck based model, and it is similar to passenger travel demand. There is a truck travel demand model, like which zones attract what truck and so on. And then there are commodity flows models that at different zonal level, what kind of commodities come in and go out. From that we can generate the truck flows and all. So this kind of models could be also developed using Cube. Then we can do change signal plans, and then we can update those signal plans and see its effect. And we can check alternative geometric designs using Cube as well. We can generate decision, we can what kind of decisions to undertake, that we can decide using Cube. So these are policy evaluation tools. We can do travel forecasting, we can do trip matrix optimization. Trip matrix optimization I will discuss later on. So dynamic traffic assignment, so this could be also undertaken using Cube, and traffic micro simulation could be also undertaken using Cube. So the basic component of Cube is Cube base. So this is the main, the base component that we have to start with. It gives us a user interface, and this through which we can do detailed data input and output, and we can also do analysis. And it can call Cube GIS. So this is where data editing, mapping, and all these things is possible. So there is the GIS component of Cube through which we can develop the networks, we can draw the networks and so on. Then there is the application manager, where we can design, document, and calibrate the models. So that means there are some models already built in. We can now do a little bit of calibrate those models, and then we can also use those particular models, and we can change those certain models. And then there is scenario managers, through which we can actually create, run, and manage different scenarios. And finally we have got Cube reports to add different reports that could be also generated using that. So two more features of this Cube software is it could be located in the cloud. So the models, data, everything could be shared, and different users can have different access, or it could be a cluster based model. It's two different architectures. So things could be stored in clouds and shared, and cluster actually helps to increase the simulation or the computational capacity by running across multiple computer processors, so that means it will reduce my cost of servers and so on. So this is the two features of Cube that are positive features, which is not there in many other softwares. So this is how the Cube interface looks. The topmost part is the one from where we control different things. This is called the ribbon. So over here, if you see in details, we have got generation, distribution, freighter, matrix. So these are the different broad components which we can actually design. So we will see those later. So over here you can see the application manager. This actually shows us that what is the kind of framework that we are using right now, how the different components, which are the components are currently in use, and what we can and how these are linked. So this is the manager, where you can see the different scripts that are being utilized, and then there are trip ends and trip. This is trip ends, and then trip generation, and all these things we can see. So this is the trip distribution component that we can see in details, and this window actually shows the data that is shown in the map. This is the mapping window, and we have a data manager from where we can connect the different databases and all, and then we have the scenario manager. So these are the different interfaces of the Cube, the different parts of the Cube interface. We also have got the applier mode in Cube. That means we don't need to modify the data and all. So this is the applier mode where you can just input data required, and the models run with preloaded algorithms, and with the same model architecture, which can be altered within limited available options. So we can load the highway networks, we can load public transit lines, we can load demographic data, and we can give in certain kinds of data sets, and then we can also run this kind of models. And so this is using the existing model system that has been developed already. Now this is running cube in applier mode, and then we can also run cube in developer mode, where you can see these details, where on this side you can see that we have got highway network data, PT lines, public transit system, public transit access links, how do you access the different stations, fares, public transit walk access, public transit auto access, intersection data. Then there is certain, then once that is there, then there is the impedance files on public transit walk, auto, this highway cost and speed, seed matrix, And so this actually, there is a feedback loop, and then see feedback loop with congested cost, and this actually comes here, and again these values are updated. So using that, we can run a cube land software, we can do trip generation, trip distribution, mode choice. So over here we can do see the entire model system, how these are connected with each other and what data is going where, and this entire framework is visible, and we can also modify this as per our requirement. We can click on each one of them and we can get into details, and we can modify those parameters as well as the model structures, and this is running cube in developer mode. So this is the interface that you get when you run cube in developer mode. So this is suitable to run customized models, algorithms, and model architecture as per the project requirements. Then we have got cube catalog. This is basically the help files that it gives us a lot of resource using which we can actually learn the system. So in Cube and ArcGIS, Cube uses ArcGIS. So Cube uses the ArcGIS engine to actually do all sorts of mapping. So the benefit of this is we can develop a shapefile or a map in ArcGIS, and we can import that back to Cube and vice versa. So this actually makes our work very easy. That means people who have already developed maps in ArcGIS can actually import them directly into Cube, and so we do this in the GIS window of Cube. So Cube, as I was showing in the interface, there was a GIS window, and we can import the data from ArcGIS directly. And ArcGIS ESRI engine in Cube helps in displaying the map, describing geographic information stored in geodatabases, shape files, CAD files, raster images, as well as other created map elements. So all these things could be also displayed in Cube. So more or less all the capabilities of ArcGIS is also there in Cube, many capabilities. So Cube can also, in addition to all this, because GIS is basically spatial data along with data. So that means that means for each point, each line, there is a database or a table behind it, right? So in addition to that, Cube can also store data in private geodatabase in MS Access MDB format. So Microsoft Access is basically a database. So we can also store data in that, and in enterprise database solutions such as SQL, Oracle, and others. So we can also link this when in case of very large amount of data, we can also use this kind of RDBMS systems. RDBMS is relational database management systems. So this the created GIS map in Cube can be saved and shared with other analysts to work in different devices as well. So that means the same map could be shared by different people. So over here you can see we have got ArcGIS. We can have this is for the maps and some amount of data. We can have additional data in MS Access, like in MS Access is a full-fledged database. If you can explore that, you will see that there are tables. Then the tables are linked also. Like for example, one could be a list of households, and then one could be a list of individuals. Then there could be ID linking each individual with each household. So then we can, once we have that, we can have very complicated query systems like search a person whose income is this, belongs to this particular category, and so on. Or we can categorize different socioeconomic groups in different complicated ways. So once we do that, that could be actually linked with ArcGIS. So this becomes my database for the spatial representation. So this is possible. Once it is done, Then based on and Microsoft Access, because we are doing transportation work, we also have data on travel demand and so on, socioeconomic databases. So that actually could be stored in Microsoft Access. And then the data on the zones, the administrative zones, the TAZs that we actually use, that could come from ArcGIS. The network data, that is also coming from ArcGIS, because we are drawing the links, nodes, everything in ArcGIS. And all this is used by Cube base or the Cube system, you can say, Cube Voyager as well. And then using that, we can do spatial analysis, or we can run the models, and we can get our results of travel demand or vehicle flows in different corridors or links, and then we can do also spatial analysis. So this is how ArcGIS and Cube is integrated. So what kind of data that could be edited in GIS? This could be roadway network data, including length of the roadways, number of lanes, road types, so on. Then intersection data, like we can model signal timings, priorities, turn prohibited, geometry of the intersection. Public transit lines, the route, the stops, frequencies of buses or whichever public transit. Then access connection to and from public transit station. I was showing you that there was a list of access links, access cost and everything. Then the polygon boundaries, polyline boundaries for different marking, different TAZs, zones, and for demographic data, spatial generators and so on. Then this is how what kind of data could be edited in the GIS part. And then we can also develop a lot of thematic maps. For example, we can do thematic mapping and using histograms and pie charts. We can do path building and skimming. We can show paths and isochrones. We can do bandwidths and dynamic displays, show volume of by direction and congestion levels. So we can mark it along in the links. We can mark different levels of volume by increasing the width of the link maybe, or we can also show the congestion levels as well. Then we can do desire lines and intersection displays, where we can see the turning flows, level of service of the intersection and so on. Public transit line information, where we can see the route, the number of boardings that take place. Then we can also embed videos and photos and other media in our maps as well. So this is how the entire capabilities of GIS is there in Cube as well. And we not only we can use this data from shapefiles or data from some databases, but also we can analyze the data, and once the analysis is done, we can also represent them in nice thematic maps or nice statistical analysis like histograms. We can create those pie charts and all from the basic statistical analysis, and that also could be displayed. So some examples. This is where we can import the base maps. See here you can see that we can import the base maps. We can import satellite imagery. We can import street maps, and this we can directly put inside our software. So we don't need to build everything from scratch. We can import existing databases directly into Cube as well, or existing street maps into Cube as well. Sorry. So this is the GIS toolbar. So in the first box, this one, this part, we can see that we can import and export GIS data, CAD files, raster files, shape files, geodatabase data. So all these things could be imported directly into Cube as well. Then this is the tool where we can create and edit the transportation features like nodes, transit, links. All these things could be edited from over here. And then over here we can also do edit and create GIS maps inside Cube as well. So we can either edit and create the maps in ArcGIS and then import it over here, or we can actually create the maps over here as well. So the tool sets are given over here, and over here we have tools to create the network. Like in ArcGIS, we have when we will show you how to do this network analysis, then you will see that we develop this links and node in ArcGIS as well, and that also could be done in this Cube software as well. So this is an example of how transit network could be visualized. So you can see the volumes, you can see the total loads at different points. So this you can see by different representations. So this is one example of transit network visualization. Then this is an example of how you can visualize the different roads. Like we can have volume bandwidth, we can have directions, we can also represent them in different colors and so on. Then we can also do this analysis visualization. That means once we have completed the analysis, we can generate thematic maps. For example, this is a map where the volumes are shown, different widths are given for different volumes, as you can see over here. And then along with that, we are using this pie charts where we can actually show the different kinds of trips, like walk trips, school trips and all. So the percentage share of each trip could be shown along with the different links. So this is a tool to customize the visualization of the analysis result, and we can create animation for the simulation results as well. So this is what we can do over here. So this GIS tool, this analysis box, we can do all this. So this we are not learning how to do this in this particular lecture. It is difficult to teach so many features in such a short time. So I will just show you the capabilities that are there, and if you get a chance, you can also explore this software on your own. So these are the things you can do in a GIS software. Sorry, in a transportation software. So in addition, we can have editing tools for intersection modeling, so microscopic simulation. So last time we showed analysis. So within that there is intersections where we can put in data volumes, turn penalties, time segments, and we can model intersections as well. We can also have scenarios, like there could be different scenarios that we can run and we can get the results. So that also could be done. Then some examples. This is visualization of trip production by purpose, models outcomes. So this is a macroscopic model, and we can see over here that different school trips and all. This I was just talking about right now. So you can see this in detail. So different volumes are being shown in different color gradients. So gray to deep black, and that is being shown here. Along with that, we can also show the different share of different trip as per the trip purposes. This is represented along with those particular links. Sorry. So this is how we can also visualize the link volume and speed, which is a result of a microscopic model. So this is how you can see that. So for different speed, you can have different different color patterns, and you can see that which of the roads it is congested, which of the roads it is not. So this is what we can also visualize. Then we can have a visualization of the land use forecast. For example, you can see that what are the share of houses, condo, duplex and apartment in those different zones, and we can have it as per the different zones. So this is again visualization of land use forecast. So now we will talk about the different components of Cube software. So the base is Cube base, and in addition to Cube base, we have got different components. Cube Voyager, we have discussed about Cube Voyager. It is suitable for macroscopic regional models for analyzing city level passenger travel demands. So this is basically the travel demand component, travel demand management or analysis component. Then we have got Cube Dynasim, which is for the microscopic traffic simulation model, which we have also discussed earlier. And then we have got Cube Avenue, which is the mesoscopic model, which helps us to understand the congestion status across a day. And Cube Avenue is very detailed. So more or less, many of the features of a microscopic model could also be done using Cube Avenue as well. So Cube Avenue gives us, if we go for dynamic assignment and all, Cube Avenue actually help us to generate those kind of data, which actually goes as a feedback to the Cube Voyager model as well. Then we have got Cube Land, which is suitable for prediction of land use changes and its impact on transportation systems. We have got Cube Cargo, where we can model freight movement throughout a city or region and to understand the impacts of commodity flows. And we also have got Cube Analyst, which is a direct formulation of trip matrices from survey data, that is roadway and public transport counts. So usually it is not possible to do this travel demand surveys or rather trip travel diary surveys. So instead, if we want to already have a travel diary survey done maybe a couple of years earlier and we have developed the models, now we want to update the model and all. then we can always do surveys of the different road stretches, then put in those data sets in the cube analyst, and cube analyst will help us to match this survey data and to build the actual trip generation, trip distribution, all the different components as well. So this is a model which is like from the results we can actually build the actual model directly. So I will explain that in details later. So starting with Cube Voyager, we will of course explain detailed travel demand forecasting using Cube in the next lecture. But just to give you an idea about what is there in Cube Voyager, we can do travel demand estimation and forecasting using Cube Voyager, and we can implement 4-stage models, tour-based models, as well as activity-based models. And this component that I was highlighting earlier, you can see there is network, highway, public transport, then generation, distribution, freighter, metrics, plot, turn build. So these are then there are other features. If you click on this, you will get other features as well. So these are the different inbuilt program libraries for the Cube Voyager. So what you can build using those program libraries, you can build the network, and you can compare and manipulate the transportation networks. Then you can have matrices like powerful calculator for demand modeling, matrix manipulation and record processing. So this is the matrix manipulation tool. We have got the highway inbuilt program library which estimates zone-to-zone paths, scheming and assignment of highway networks based on user's choice of deterministic and stochastic algorithms. So this is where assignment is done to the highways. Then we have trip generation. We can process data based on designated algorithms, using algorithms to create arrays of productions and attractions for different zones using this particular component. Then trip distribution, where we can, based on the designated algorithms, we can have OD matrices that we can generate. Then we can use freighter model where we can modify the matrix based upon a set of production and attraction growth factors. So we are in trip distribution, we have explained the formula for freighter model where we have shown that there is a factor from production, then there is a factor from attraction, and then we have to iteratively model it, and then actually that help us to develop this kind of OD matrices. So then we can also have combined mode and destination choice models where we have hierarchical nested multinomial binary mode choice models. There could be generalized cost mode choice models using aggregate logic techniques as well. So there is different capabilities which are there in the system. Then public transit advanced, there are functionalities for the analysis of any public transport system, like we can introduce different kind of fare structures for modeling public transit capacity. Then we can have different capacity restraints. Based on that, the public transit could be modeled, and this is suitable for both mixed and dedicated traffic. And then there is this pilot tool which is used for controlling the modeling process, calling modules and running script. So if you remember from our land use transport frameworks, when we discussed that, we said that there is real estate model, location choice model, traffic model, and so on. But there has to be a central controller which controls or gives instructions which to run when, in what sequence it has to be done. So that is what pilot is. So pilot helps in controlling the modeling process. It will helps in linking up the different modules or the components and how the data flows between these particular components. So this actually calls the different modules as well as run the different scripts. So then we have got Cube Analyst. You can take a look at this particular screen. First, let me tell you what Cube Analyst is. Cube Analyst calculates the most likely travel patterns between neighborhoods from count of cars on roads or passengers on buses and trains. That means if I get counts of passengers from the roads and then from our transit networks, if I load those data, then automatically it can tell me that what kind of travel pattern is there from one neighborhood to another or from one zone to another. So that is, you have to load this particular data, like you have to have a network file, then you have to load the original trips, estimated trips are estimated, and then we have This is a static method. There is maximum likelihood method is utilized to determine, okay, because of this kind of flows that we are observing, what is the actual generation at different zones. So that you, based on probabilities and all, it will actually do those estimates. So we have got turn flows at different intersections, network flows, and then other things like highway trips, trip ends. Trip ends means when there is a shopping mall or any kind of facility, we can also estimate how many trips actually go there. So we can do surveys of those particular facilities. So from there we can get that. From highway flows could be got by surveying at screen points and so on. So these are the data that could be entered into the system, and it will generate us this OD matrices. So just to give you just to detail it out, the first step is to load a trip table on the network to get basic OD metrics using Cube Voyager. And what Cube analyst can also do is, if we already have done this, then a Cube analyst can adjust the trip table for better match with the actual observed values. So that is also could be performed by Cube analyst. And then the data could be again transferred to Cube base for visualization of travel pattern to Cube Voyager, or to Cube Voyager for planning applications. So from Cube Voyager, the data that we are predicting and from the trip tables, whatever OD matrices are generated, that could be analyzed with Cube analyst using the actual flows that we observed from surveys, and those two could be matched actually. So Cube analyst does static estimation of private and public transport matrices using maximum likelihood method, whereas Cube analyst drive where we can do also dynamic estimation using data assimilation techniques. So these are the two techniques that are being used, and the input data is trip end data, means what kind of data this Cube analyst takes in to give us the modified OD matrices. These modified OD matrices are finally used for forecasting and all. So this trip end data, traffic count data, path data from origins and destinations. So these are the different kind of data that is inputted into analyst, and we get more modified OD matrices which matches with our which could be also integrated with a forecast, and so that our model is more robust and actually matches the conditions that we observed in the network. So then we have in Cube Avenue, this is the macroscopic model for Cube, and as I told you, this has got many capabilities almost similar to the microscopic model. So this is our next extension, Cube Avenue. So here dynamic equilibrium traffic assignment actually could be undertaken if we have Cube Avenue. So normal Voyager cannot undertake it. But if I want to undertake dynamic traffic assignment, then we also have to have Cube Avenue. So data requirement is less than microscopic simulation. And here traffic as individual vehicles or as platoons of multiple vehicles, both could be done. Time increments in terms of minutes or hours. That means every minute we can have change in the traffic conditions, or every hour we can see what changes in the traffic conditions. Intersection characteristics could be modeled. Variable road pricing and lane closures could be also modeled. Impact of upstream traffic congestion, that could be modeled. Queuing at that means if there is an upstream traffic condition, then there is a shock wave which also needs to be modeled. That means the speeds will also decrease in the downstream corridors. So then queuing at intersections and merge points. ITS, different ITS components could be also incorporated, and using this, as you can see over here, we have this network file, and over here we have this avenue, and there are truck trips, there are intersection data, there is network file. Then over here this side there are dynamic loads, dynamic turns, turn volumes, all these things could be predicted, and based on that, and we have hourly trip metrics. This is the initial input. That means if you remember for traffic assignment, if we have given the hourly load OD metrics, and then we had seen that okay, how the assignment takes place, then what is the update in the network, how the impedance is increasing in the network, that actually gives the feedback, and then my this other decisions also change. So this is how this avenue is connected with the network component, and the network travel times are updated, and that actually could be updating my Voyager as well. So all these models could be linked together. So what kind of analysis we can do? We can do policy change analysis. That means if we change certain infrastructure, if I change certain kind of operations in a particular road or a corridor, what effect it will have. We can also manage emergency. We can also do emergency evacuation plan and see its effect using this kind of models. Then stadium entry, exit, and other special events could be also modeled using this kind of, means their effect on the network could be also modeled using this cube avenue component. Then we have got cube cargo, where you can see this is analyst, this is analyst drive, this is avenue, this is cube land, this is cluster. We can run the cube in cluster mode. Then this is cube cargo. So in cube cargo there is production, distribution, logistic nodes, fine distribution, vehicle model, and service model. So these are the different components. I will explain how these are linked. So this is how cube cargo is linked with the different components. So we have cost by different modes, times by mode, distances, fine distances, and then service vehicles. This will result in this commodity matrix and vehicles. So this commodity matrix actually could be used to determine the total commodity, the total peak truck flows, and what kind of vehicles could be used for this distribution. So this is how the entire thing could be modeled, and urban and regional freight commodity flows could be forecasted using cube cargo. Freight vehicle matrices and policy value. So we get freight and vehicle matrices, means freight means total amount of commodity that flows between different zones, and also the total vehicle matrices, that is the vehicles resulting from freight. So commodity is not same as vehicles, because the commodity has to be then converted into both vehicles as well as trips undertaken by the vehicle. One vehicle can take multiple trips, or one vehicle can serve many zones. So we have to also model that separately. So we can do this for different evaluations of different kinds of policies. So when we discuss, when we have covered freight planning, you can again revisit this particular lecture, and then you can see the capabilities of cube cargo, and then you can probably relate both of those. Sorry. So what are the different components? Like the first is cargo generation. So we estimate of cargoes in tons of goods produced and consumed by commodity class by each zone. So for each zone there is production of certain commodities and consumption of certain commodities. So we actually model the commodities. So we don't model truck flows, we model the commodity flows. So this is one form of model. We can also have truck flow models as well. So then we do mode distribution, where estimation of matrices of tons of good by commodity class segmented by short haul and long haul. So we do OD matrices. So some are short distance and some are long distance. Now why short and long? Because different logistics model apply for short, different logistics model apply for long hauls, means when the length of the trip is longer. So mode choice also will vary accordingly. So estimation of matrices of tons of long haul goods by mode and commodity class. So once we have different commodity class going for longer distance, what sort of mode choices will happen? Then we have the logistic nodes model. So here we partition the long haul goods by mode and commodity class by direct transport and transport chain routes. So certain things are direct trips, like for example, I deliver coal or steel from one point to another. But if I am delivering like a certain kind of item like refrigerators, now I am going to 4 distribution from my industry, I am going to 4 distribution centers. So I have to, my vehicle will go to 4 distribution center one after another. So that's a transport chain tour. So that has to be modeled. So this cannot be modeled using in the same way. So some are round trip tours, some are direct one-way trips. So each one has to be modeled accordingly, or depending on what kind of logistic decision that we undertake. So that means I can send a vehicle and the vehicle then returns empty, or this vehicle can go and pick up goods from another area and then return back. So there could be several options that could be modeled. So we have discussed we will discuss all this when we cover the freight modeling, and then you can learn, you can again come back and see how this thing matches, how this software matches with the capability, this capabilities matches with what needs to be done in freight planning. Then we have a fine distribution model. This is for distribution of code zones information to the final level zone system, and this is for micro level modeling, that is within a zone, how to move within a zone and so on. Then we have the vehicle model, estimation of number of vehicle tours per day by vehicle type, like different types of trucks and so on. So then we have the service model, estimation of matrices of local truck travel for local delivery and services. There are certain local deliveries also take place, so that also could be modeled. So this is how cube cargo is could help in freight planning. Then there are a few other extensions like cube flow, where you can plan for the transit operations. Then you have got cube street analytics, where we can understand who, when, where, why, and how people move, and this kind of things. Then we have got cube sugar, where they provide complete solution for managing, analyzing, and visualizing transportation networks and accessibility at community level. So this actually helps us to determine accessibility and so on. Then there is sugar access and sugar network data. So these are components of this thing. Sorry. So then coming to how do we conduct a land use transportation integrated model in a cube, and this is where cube land comes in. This is one of the extensions, of course, and now cube land individually, it's one component. It is basically used for modeling real estate development and so on. So you see over here we have got network loading, accessibility, intersection data. So this is the input to any kind of land use transportation model. And then we have the travel demand model, where we do trip generation, trip distribution, mode choice, and traffic assignment. And from there we can have trips by mode, network loading, and all this. So this is trip assignment. And this traffic assignment actually results in the trip load in the different network, which could be visualized and so on. Now this network loading, accessibility, intersection could be also taken input in cube land. And along with that, there is input from socioeconomic profiles of samples, travel analysis zones, all these things. This basic demographic and other administrative zone details could be also taken in cube land. When we take that, we can model using this, can model the real estate developments, and then using a walk and residential location choice model, we can actually decide where people will redistribute themselves, or what would be the total household in each zones and so on, final. And then this actually goes as input to the travel demand model, which eventually help us to determine what kind of flows are there in different corridors. So cube land, this is where interaction of urban land and transportation system happens. Cube land can actually model or rather consider economic growth, changes in population, employment and wealth, changes in population, employment and wealth in a particular area, then urban growth management policies, specific real estate projects, and transportation projects. So this could be handled by cube land, and we can evaluate different smart growth principles and toll road infrastructure, if we want to introduce those, what effect it will have, sustainable community development, greenhouse gas effects, and gentrification analysis could be also analyzed using cube land. So this is how cube land is placed in the overall framework. So we have got cube land, and then cube land inputs from that goes into the trip generation model, and then subsequently trip generation, trip distribution, everything is connected, mode choice. So all these models are connected both and they have feedback from each other. So this is how it is done, and for cube land, the entry is basically the socioeconomic totals. That means this actually goes into this model, then zones, then highway level of service, then public transit level of service. These actually are things which influence decisions on real estate, that is could be modeled using cube land. So this is a tool for integrated land use transportation modeling. Different econometric modeling techniques are applied in cube land, and this is integrated with all cube base, Voyager, ArcGIS, so on, and other components, and we go for equilibrium convergence over here. So as we have talked about equilibrium and disequilibrium when we are developing this real estate models and all, so equilibrium is considered. So to conclude, Cube offers a modeling framework which is easy to follow due to its interface, and Cube along with its extensions offer different tools and capabilities to carry out an integrated land use transportation plan. It also offers a custom scripting language to customize the models and their connections, and full GIS support through ArcGIS engine. And Cube Voyager could be used for both the 4-stage travel demand modeling and advanced tour-based and activity-based model. And we will take this up in detail in the next lecture. So this is some reference. You can go to the City Labs website and you can look into the software. Thank you.